Thank you. Okay, I'm also the original co-author and project lead for Bosun and scollector. So if you don't know, what is Bosun? It's a MIT open source monitoring system. It's under the MIT license, built at Stack Overflow. Its emphasis is really on alerting. It includes an IDE for building alerts, and part of that is a typed and set-based expression language. It's kind of like Pandas or R, so it's a domain-specific language we built for alerting. There's also a templating language for notifications that integrates with the expression language, so, and that's based on Go's templating language. We also have historical testing, so you can take alerts and see how they would have performed over history, when they would have triggered, when they wouldn't have. And then there's a dashboard for an alerts and alert handling workflow, and it works with different time series databases. So the main one's OpenTSDB, but we also support Graphite. InfluxDB is a bit experimental, but it's in there, and Elastic when it's been populated by Logstash. You can query for time series information as well. We also built an agent called scollector. It is not required, it's optional. Like Bosun, it's built in Go, so it's multi-platform. At Stack Overflow, we're a Windows and Linux shop, so we needed an agent that did first-class monitoring for both. It also allows us to do auto-discovery, which in turn results in auto-alerting. So when you add new things, it sends new data, and if you've written your alerts correctly, it's going to apply to that new host or that new thing. So you don't have to be updating the config as your environment is changing that much. And it does various polling too. Some of the neat features of the collector is it'll queue up data if the data store can't be reached. So that way, if you have a network blip or something, the data is going to flow in afterwards with the original timestamp, so you can go do a little bit more forensic work there. The data frequency by default is every 15 seconds, so that's a pretty decent resolution. It's not down to the level of on-box profiling, but the idea is to give us enough so we can really see the shape of data and get enough samples that we could start to do some significant alerts. And it'll provide some metadata about the metric. So what is the series type of this metric? What is the unit? What's a prose description? So as a consumer, these are all things you want to know about as a metric, so it sends this. It also sends some tag metadata. So for example, like host equals nyweb01, we're going to have serial numbers, the OS string, stuff like that. So this is some of the stuff scollector currently monitors. I don't know how readable that is. There's Windows and Linux stuff, Redis, Puppet, desired state configuration, Active Directory, HAProxy, all sorts of various stuff, and various stuff that it pulls. So Stack has a fairly extensive monitoring stack, and this doesn't even really include everything. We have various data sources, scollector, of course. BosunReporter.net is what we use to implement our applications. We do a lot with our weblogs. The web servers will send various response setters, such as how many Redis requests were made, how many SQL requests, how long they took, and that gets parsed by HAProxy and then stripped before it goes to the client. We then send our logs to our TPS service, our traffic processing service, which will send data to Bosun, MS SQL, and Logstash. And we do the same thing with our system logs and Windows events. And we also have this client-side performance sampling. So for every, I think, 1% of users that visit Stack Overflow, we have an extra JavaScript request that goes and sends our client timing. So in Bosun, we could see like how long the DOM render took for our actual users. This gives us some real performance monitoring. We need databases for all this, so we have OpenTSDB, which is on HBase. We use SQL, Redis for Bosun's metadata now, Elasticsearch. For dashboards, we're using Grafana, Observer, Kibana. Observe is another open source monitoring project from Stack Overflow. Alerting and notification, Bosun, of course, but we have PagerDuty combined with Pingdom for an external backup view. And then we have some specialized monitoring, such as extra hop for network traffic, which is passively switching .NET exceptions. We monitor an expose for security. And then Observer has some specialized monitoring, especially around SQL Server, but Redis and Elastic as well. So that's a pretty big investment in monitoring. So what does investment look like day to day? Usually we're creating dashboards, we're doing data collection, we're working with developers to instrument their applications, we're analyzing logs, we're doing scripts, agents, creating, handling, tuning alerts, and if you're crazy, you're creating a monitoring system. So why make this investment? For me, monitoring has a lot of positive attributes besides just its direct effects. I think one of the main things is that monitoring is a good way to improve our mental model. So for all of our systems, we have this mental model of the system, right? And that picture we have in our head, that mental model is going to have a varying degree of accuracy from the behavior of the actual system. There's no way we're going to capture a complex system entirely in our head. So monitoring is a way to grow that mental model, to get to know the system better. So for example, if you're a kernel dev or an advanced Linux network admin, maybe this is the way you think about network data flow through the kernel, right? This would be pretty impressive, but it's probably normal for a kernel developer. An entry-level sysadmin is going to have something kind of more like this that we're all used to. You have user space, and then the kernel is handling TCP, IP, Ethernet, and driver, and all that sort of stuff. And then you might have the naive model of a bunch of pneumatic tubes, which would be the model for an unemployed sysadmin. So these activities of monitoring make us ask questions. And when we ask these questions, it improves our mental model. So for example, with data collection, we're asking things like, what does this metric mean? Why did the developer make it available? Should I display? Should I alert on it? How important is it only for forensic analysis? And then as a developer, you're asking yourself similar questions too. Should I collect this information? What should I name it? What's the point of it? Creating dashboards, we do the same thing. What is the scope of the dashboard? What do I really want to communicate? I think dashboards and alerting are a lot about communication. How should I visualize it? What metrics should I display? Should this be a bar chart, et cetera? This is Stack Overflow traffic by continent for each of the plots, and then each color is a country. This doesn't really have a purpose, I just like it. I like the way you can see the time zones, and I also like the way it kind of looks like Mexican bead art. Back to the presentation. So for alerting, you need to ask yourself things like, what alerts do I need to create? And that could be proactively, such as, I think this could be a problem, so I'm going to create this alert, or what alerts do I need to create so something that impacted us again does not catch us off guard? And you need to decide who does it go to, what is the scope, what is the intent, how do I communicate it, how do I make it less noisy? So there's a lot of decisions, and all this builds our mental model. So good sysadmins tend to have good mental models. They'll have ones that are specific to their systems, a very good working understanding. Also, we develop heuristics over time based on our experience with systems, right? That's something that we gain with experience. And if you have accurate mental models as you grow as a sysadmin, then your heuristics are going to be better too. If you don't do that, then your heuristics are probably going to be more shaky. I think better mental models result in better choices as a system, in designing system, troubleshooting, all this sort of thing. I also think monitoring is a good way to build a mental model as things seem to be getting more abstracted, right? We're getting containers, even hardware APIs are having more levels of abstraction, and this is all great, right? It makes our job easier, except when it doesn't work. When it doesn't work, we need to understand how it works underneath, and I think that monitoring is a pretty good, safe way to do this. There are, of course, other ways. There's documentation, there's config management, there's deployment, there's just setting up labs and playing with stuff, right? This all helps, but I think monitoring is a good, pretty universal way, assuming that what you're working with was well instrumented to start to get to understand something. I think it can help with decision-making efficiency. So when you're collecting data and you have a wealth of data, people on the team, instead of using educated guesses, are going to just look at the data if there isn't too much friction. And that can really avoid what I call arguments of fact. Sometimes people just argue about whether something is expensive or not. And if you can just measure that, it's a waste of time to argue about that, right? I think data-informed decisions should lead to better decisions as a general rule. And when you communicate by sharing the data that led you to your conclusions, it builds trust with people because they realize you're not just kind of using your heuristics and guessing, you're basing your choices on data. And it also helps them understand how you reach that conclusion because then they're sharing your context. Another big thing I think monitoring helps with is reactive operations. So reactive operations are really when you spend too much of your time reacting to basically active situations, things that are broken right now. What this feels like is that you're constantly playing catch up, you're constantly behind. A lot of us have probably had these jobs, right? Whereas proactive work, you're working on what I like to call latent issues. So latent issues can be known or unknown, but they're basically the little time bombs throughout your systems, right? Things that aren't causing a problem right now, but certainly have the potential to. So when you're in a more proactive mode, you're working on those latent issues more. So I tend to think of reactive operations as the enemy, but they're also inevitable, right? There are consequences to complex systems that no one will ever foresee. Like sometimes you do post-mortems and you're like, no one ever would have thought of that no matter what we did. So one of the things I like about monitoring is that it really helps with both. So as far as preventing reactive, you can create alerts that warn about impending resource of availability, basically health check alerts that tell you something's unhealthy, hopefully before your users know. You can also just watch dashboards and maybe pick up some aberrant behavior that could be a latent issue that's waiting there. And borderline is maybe you'll just pick up things that are affecting users, but at least before the users report them, right? When a user reports an error, in my mind, that's like monitoring fail. That's the first thing that comes to my mind. And this also helps when we are in reactive operations, because when you're doing the work of monitoring, the data collection, alerts, dashboards, all that stuff I talked about before, all that stuff should communicate the state of a system more rapidly to you. And then through all this work, when everyone has a more accurate mental model, then they should be better to face sort of the unknowns, because they understand the system, and they didn't know this thing could happen, but at least they understand the system well enough that they can interpret it more rapidly. So to summarize this section, why invest in monitoring? Improve our mental model. I think that's incredibly valuable. Improve our decision making, very important in a larger team, and decrease that time spent in reactive work and make us more effective in those situations. So why invest in creating a alerting system, right? This is where we start to get a little crazy. I found that I was stuck with the limitations of other alerting systems. They would often just be threshold based on a few recent observations, and that doesn't really match real-world complexity of our systems, right? Our systems are a lot more complicated than that. And I found as my mental model for various systems I wanted to alert on would improve, I wanted the specificity of my alerts to improve too, and I couldn't. So there was that cognitive dissonance, which was just uncomfortable to have these alerts that don't match to my environment. I mean, that's just kind of a, more of a sysadmin thing. But more practically, it results in alert noise, right? You get these alerts that are false triggers, and you can't correct them because the power's not there. So more specifically, I think what was needed was the ability to get historical data, to reduce the time series in flexible ways, different reduction functions, and different times of span. Time spans. Booleans to create logic, so you can say things like, if this is true but not this and not this. There are lots of situations like that. Forecasting, being able to see things like do regressions on disk space and alert on how many days until I run out of disk space. Not that I am out of disk space, because that's, again, reactive versus being proactive. And another thing, which I'll get into a little more later, is an alerting scope that's capable of being decoupled from the data model, so that your data model, the way you collect that data, might not be the way that your alerts trigger. And if you have to go and then change the way you collect data every time you want to change your alert, that's too much friction. It's not a good workflow, and people tend not to do it. So that needed to be decoupled, and our expression language lets that happen in Bosun. I also found notifications were limited in that, including graphs, tables, links, metadata, if it was either not possible or it was pretty hard, because things were too decoupled there. And then the alert development workflow, everything I looked at lacked testing, which means you can't really know if alert is going to work or not until you throw it into production, which then results in a lot of noise too. So Bosun and scollector each have their roles in this. Bosun's mission, fix alerting. Basically, expressiveness, alerting conditions, and notifications, so we can get accurate alerts that will get rid of the alert fatigue from too much noise, and then provide an interface that provides a good workflow for both handling these alerts and developing them. scollectors was data collection, support Windows and Linux, like I said, enable that auto-discovery, and then send the metric and object data. I found this needed some just fundamental agreements. It needed ingredients. It needed a time series database, expression language for manipulating the data, a templating language for the display layer, and then a good workflow for developing, which is kind of just traditional development workflow, which is kind of interesting. So anyways, to get into this, let's start to look at Bosun with an example alert. So we have HAProxy. HAProxy has a session limit, and I wanted to, still a basic threshold alert, but we'll see how this lets you do some things with that. We hit a session limit on one of our HAProxy limits, so this was one of those never again things, set up a data so we know that's happening. So the first step is to query some data. We have metrics. The data model that Bosun works with is the idea of time series that are tagged by key value pairs. That's what we see in Influx, Prometheus's database. With Graphite, we kind of make it happen by specifying the keys for the positional name and the metric. And then you have things like aggregation, adding them up, series type, and metadata. So here's Bosun's interface. Is this playing? Oh, it is playing, but I can't see it on my screen. So you type in the metric, and in this case, it's the current number of sessions. We're going to have things like the aggregator. That's what's going to happen for tag values that you leave blank. The series type is what we get from the metadata. And then, oh, this is going ahead of me. Sorry. And then we get a bunch of results. So you specify stars for each tag values, and that says give me all the results. And then for each of these results, what this graphing page is going to do is take us to the expression page. So it generates the expression for us, which we can see highlighted there. And then below that was that metadata description, so you can at least understand what this metric is. The next step we want to do is start to create an expression with this data. So we query, which we built with that querying expression. And then you want to reduce, combine, and manipulate the data. Excuse me for 1 second. Sorry, the video does not play on my laptop, so I can't see what's going on. So here we have the expression. You can, this was what was generated by the graphing page, and we see different results here. Each one of these groups has the potential to become an alert, and we can see it's telling us what the host is, what the front end is, and we can see that it's a time series result. So we have timestamps and values. We can't alert on a time series, right? We need a single decision, yes or no alert. So ultimately our goal is 0 will not fire alert and 1 will. So the next thing we need to do is reduce this metric, and we can use average. So as opposed to getting a time series as a result, we get a number, just a single value here. And this is the current average number of current sessions over an hour, I believe, is what I queried. So an alert, we want to start to get a percent. So we're going to take the current number of sessions, divide it by the limit, and multiply it by 100, and that's going to give us a percent. So when we add these operators on different query functions, basically what they do is join based on the tag sets. So when the tag sets line up, it's going to line up all of those in the expression. And we can see here the kind of a breakdown of the computations for the expression, so we can follow how it was built up. And then from here, we can go to the final page, which is the rule page. So it's going to take this expression we built and insert it in the rule page. So for the rule page, we want to start to use some variables to make it more expressive and comprehensible. You can actually do that in the expression page now. That's a more recent update since I made this screencast. And you also want to start to work on the template, making it so people can orient to when they get the notifications, they can interpret them and actually understand what this alert is about. So first, this is the config editor. First thing we might want to do is just rename the alert, rename the template associated with it to something sensible. And then we can start to create some variables. So we think of things we're going to reuse. The time is going to be in a few of the queries, tag set, and then we start to name some things too. So the time, we could say 1 hour. In truth, this would probably be a shorter time if it wasn't just a demo. And then our tag set is going to be used in a few things. And we could start to, this is all just text replacement. So it's not really interpreted variables, it's more just macros. And so we can start to do this and really make what we're saying here more readable to someone who's trying to read this expression after we've written it. So we can just calculate the percent by now saying that current divided by limit times 100 is our percent. And then we can set some thresholds in our warn encrypt possession based on thresholds in this case. And then we can see what the results would have been at that time. So the next thing we want to do is start to work on the template. So this is what this gives us a preview of the template. So right now it's not very interesting. So we first want to work on the subject of our email. And we can do things like HTTP posts, et cetera, too. It's not just limited to email. So when we do this, we can use something like the eval function. And that's going to evaluate expressions that were defined in our template. And it's important to note that we don't have to actually use expressions that were just used for the alerting condition. We can include whatever we want. So that's going to let us have more flexibility to provide context to this information. And now we can see, okay, that's a better subject. So then we want to work on the body. So one of the nice things is we have a header subtemplate that will always reference a variable called notes. So this variable basically is a dual function. It'll comment the alert definition itself, but it's also going to appear in the notification, and that'll solve the problem of, assuming it's written well, why did someone even bother to write this alert? What am I supposed to be doing with this? What does this mean? And that's really what notifications are about, right, is communication. And we also create an expression here. So here's an example of an expression that's not actually used to determine the condition itself, but to create a graph. And when you create a graph, you usually want a bigger time span than the alert itself, because that's what gives you the context, right? You can see what's been happening now and how does that compare to what's been happening in the past that alert is now triggered. So in the body, we can include subtemplates, and that's that header template. I'll show that after this. You can make tables, so good things to put in tables are the various breakdowns of information. So when someone gets this, they don't just see, I don't know, 80%, but they see what the actual limit is and what the current number of sessions is and what that percent comes out to and things like that. And you can do printf formatting, and there's various filters we have. So alerting really starts to become a little bit more like programming than it does just turning some knobs. Then you can see what the template looks like here. You have that description, you have a graph at the end. So this is what the email is going to look like to you. Sorry, I'm going to make a bad noise again. Yeah. This is the header that I talked about before, so that we have style tags at the top. One thing with email is that it doesn't respect a style block at the top, so we have something that'll embed it. It'll inline all the CSS, so you can actually define this header to give some style, and that'll all get inlined to the CSS and to your HTML here, so it actually works in email. And you can also, and we also include things like the links and the key and the incident number and that notes variable that we saw before. And these are all the things that communicate to the user. I think one of the real neat things is the historical testing. So with the historical testing, we can test to see if an alert would have triggered or not triggered when we expected, and you can tune and update the alert in rapid iteration. And this is a way to stop the noise, like I said before it goes into production. So the way this works is you set a start date and an end date, and then you're just going to execute it. You can choose how many runs to do, how many or what interval to do, and it'll fix the other one for you. And then you can you'll get a timeline back. And that timeline is going to show you for each object when it would have triggered and when it didn't. So most things are green, but as we scroll down, there is going to be a little yellow sliver there if you can see it. And we can click that and see what the alert would have looked like at the time. And this is what the alert would have looked like at that time. So we can see if it's noise or not, interpret, and then tune the alert if we need to. So the OODA loop's pretty popular. The idea is observe, orient, decide, act, and this really applies to the workflow for me, the development workflow of alerts. So we can inspect the alert from our tests, and then we can decide whether it's signal or noise. We can tune it, and we can ship it, and we can do all of this in either minutes or an hour, whereas when you don't have testing, it can be weeks or days before you actually get those results and see if you didn't get alerts or did get alerts that you shouldn't have gotten. So as far as things I've learned on composing alerts, one of the first important things is to figure out the correct scope. Like I said, the scope doesn't tie to your data model necessarily. So there's scope to the final tag set, and we provide various functions that'll let you transform and pivot that final group so you can have for alerts that are more all-encompassing as opposed to individual alerts per object. And when you have an accurate scope, it means you're going to get less notifications per incident, right? You'll get a better ratio there. A broader scope does mean more complex notifications because you're going to want to include all the breakdowns of the information in the notification. So for an example, we have Stack Overflow's HAProxy setup, which is a couple of failover clusters. This is simplified, but you'll get the idea. Various load balancers. Then within those load balancers, we have multiple instances of HAProxy running, and we call those tiers. And then within each HAProxy instance, we have multiple front ends. Front ends point to back ends, and back ends have multiple servers in them. So there's lots of things and nesting going on here, right? So you could alert host-based, right? This is the traditional thing. I'm just going to alert whenever there's problems on hosts, but if a tier has a problem, that means you're going to get 4 possible alerts. If you did a tier-based and you have 3 tiers, it'd be 3 tiers. If you did tier and host, you have 12. If you do it per those servers that are in the back ends, you're going to get a crap load of alerts if just a few servers go bad. So choosing the right scope is important, or you could do it by cluster where you get 2. And if you want, you can even do the whole service. You can just have one alert that's going to trigger when things are bad in the service. It's going to break that down for you. Sometimes scope goes wrong. So this is, we have a patcher client on all of our Linux boxes for updating the system, and it failed across everything. So this was basically an incorrect scope. So what we discovered is there's basically 2 categories of services for us. There's ones that are agents that run on all of our boxes, and we actually want that in a separate alert because those are going to tend to fail as a group. And then we have more individualized services, which we'd probably want per host. So another thing is to figure out the best way to reduce the data and pick the right time span. This is going to vary depending on the alert. So for example, a human behavior compliance alert is people sometimes leave Puppet disabled. So we have a metric, and it's 1 when Puppet is disabled. So if we measure over 24 hours and take the min of that, if the min is 1, meaning it never hit 0, that means it was probably, at least based on the 15-second observations, disabled for the entire 24 hours. And that's when we would trigger the alert, because what it means is that someone probably forgot to re-enable it when they were done. And this is a good example of kind of a latent issue like I was talking about before. If this goes unnoticed, then something's going to get more and more out of compliance, and then all of a sudden if you fail over to a box that hasn't been updated, then boom, right? So this is one of these time bombs that may not be affecting you right now, but it could. Resource saturation, you're generally going to want more time, and maybe something like a percentile. So if I just took 4 observations a minute for 1 minute and tried to figure out if my disk time writes are taking too long, that's not really enough data. So I want to span the time into something maybe more like 10 minutes. The only downside is the more time you base your query on, in general, the slower the alert will be to trigger. But that also means you have more data to make a better decision about whether it should trigger or not. So that's always kind of a balancing act. Kind of an advanced sort of and neat one is to reduce a time series with a least squares regression and then forecast it. So you can say, how long does it take until I'm going to run out of disk space? So I've had cases where I've gone to a developer and said, hey, we're going to run out of disk space in 20 days. And they're like, what? I'm like, based on the trend, we're going to run out in 20 days because of this problem. So if you can fix it in, say, the next week, that'd be great. And they're like, what? You mean I don't have to stop what I'm doing now? It's like, no, just fix it eventually. So that, again, is kind of this proactive mindset as opposed to this reactive, like, oh, my God, there's 1% data space. You need to stop what you're doing and fix this now or help me fix it. Also, another common situation is to use Booleans and dependencies to limit under what situations an alert will trigger. So on our CPU alert, we have Elasticsearch running. So I have this query that we have these lookup tables, which I didn't show here, but they're basically like case statements. So I say, is this a search box? And if it is a search box, is this other operation going on called fetching related questions, which I know is expensive on Elastic, and it happens at various times. So what I do is I monitor that job as well, and I say if the CPU is higher than it was historically in this case, don't worry about anomalous CPU if it's a search box and this job is running, because I expect that behavior. But the high threshold alert, the high threshold aspects of this alert will still be in play. So if it saturates to 100, I'm still going to get alert. I'm just not going to get that it's higher than it used to be aspect of it. We have dependencies too, which is just you specify other alerts, and if that alert is triggered, this one won't. So Bosun will ping hosts at scene, so if the host is down, don't alert about other things on the host, stuff like that. Finally, you want to design a notification that really communicates well. I think good notifications, the key, and it's hard, is to pretend you're not the one that wrote the alert. And that's a pretty tough thing to do for anyone. But when you do that, you start to learn some things you need to do, like that notes field. Explain why I created this alert. Have a prose description explaining why, under what conditions this will trigger, so they don't have to interpret a complex expression on the fly. And then you want tables and visualization. So here's an example where one of the IIS applications hit 40%, and we got this alert. But in the notes, I don't know if you can read it, but it says it's limited to 40%. So if I got this alert and that note wasn't there, I'd be like, why am I getting an alert for 40% CPU? But since the context, the operator provided the information, I'm like, oh, so this is saturated. Same with disk space. This is a forecast one. It tells us what the percent is free, and then how much space is used, what a 7-day forecast estimates, what a 1-day forecast, what the deviation has been, and you can see that the disk space is definitely starting to decline quickly. And this is for historically anomalous CPU for processes, so we can see what the process is and what it looked like over the past, what the current median is, what it used to be, what the calculated threshold was for this alert, things like that. For alerts that cover broader scopes, we have these breakdowns again. So this one would cover basically a whole bunch of down servers within a backend of HAProxy, and it's just going to list which ones are down. And again, we have that with Redis replication. So we have a bunch of Redis instances, and they span a geographic data center. So when replication breaks, it tends to break on multiple of them, not always. But this way we get an alert, and in this case they were all broken, but it'll show us which ones are broken and which ones are not. But it all comes in a single alert as opposed to getting this, however many Redis instances we have, one email per. And again, that helps with the noise. So as far as what's new and coming, Bosun was released about a year ago. I spoke about it a few days after it was released here, about a year ago, so it's been about a year. I created a new Grafana data source plugin so you can graph Bosun expressions, which is pretty cool. It's very useful because you can do things like filtering and limiting and multiplication and all sorts of manipulations you might want to do. Grafana is working on data tables right now. They released that yesterday, so when we have things like average web CPU, I'm looking forward to including those data tables once they add that. OpServer, that other open source project from Stack Overflow I mentioned by Nick Craver, this is a picture of it feeding from Bosun now. So it used to pull from Orion, so we're moving that so it can pull from Bosun. And this is more of kind of like a host-based traditional view, which still has a lot of value. The idea of Bosun is that it doesn't have to be host-based. You really are configuring things based on how your environment is built, but this host-based view can be very nice. This is a mock-up that the people at Grafana made. They're starting to talk about alerting. Their plan for their first iteration is to use alerting that's built into Grafana, but it will be using Bosun's expression library, which they've imported into it, from what I've been told, and it'll be able to expose the expression. So for people that want to be able to create them easier, you'll be able to use this and see what it would have looked like and maybe copy that into your Bosun instance. In general, performance and stability is getting a lot better. We used to just serialize these giant Go objects to Bolt, and it was terrible. Now we're using Redis. This transition is almost done. And if you don't want to use Redis, it actually has a standalone thing called Redis. It is a Redis implementation in Go. So if you're just trying it out or your small installation, you won't have to install Redis, but you can say use Redis instead of this built-in one, which should be faster. OpenTSDB 2.2 is adding filters, which lets you filter out your aggregates. So you can say only filter some subsets of the tag. That's in a branch. Support for that should be coming soon. So lots of stuff is still being worked on, and we're constantly adding things to scollector and more monitoring. So in summary, accurate alerting, I think it improves the mental model and reduces alert noise. It helps prevent that reactive situation. It makes you more prepared when you are in a reactive situation. And that Bosun was developed to have the power and workflow to enable these precise alerts, so you don't have this dissonance between your systems and your alerts. So if you want to get involved, we have bosun.org, and we have a Slack room. There's an inviter on that page. We're always looking for scollector and more Bosun contributors, or even if you're just adding examples and correcting documentation for us, it's definitely appreciated. So that's pretty much it. I don't know how fast I was, but I lost some time at the beginning, so that's good. So questions? Ooh, hands.
So one of the things that I've really wanted to try to find somewhere in some alerting package that I haven't seen yet is basically multi-tenancy. I would love to be able to provide alerting as a service to my users, because a lot of times the sort of things that they care about, like some research data set file system is full, are things that either I don't care about or I couldn't do anything about even if they actually were triggered.
So for each alert is hooked up to different notifications. So we have, currently there's really only one configuration file, and you can filter on the dashboard to only show you the things you care about, and then have the notifications go to the correct people. We don't really have any idea of Bosun. There actually is no authentication currently either. It's just open. So we don't have an idea of, not for adding the config, but for all the other stuff. We don't really have an idea of multi-tenancy. We actually just got an issue on that today in the repo. But you could run multiple Bosun instances, and I know people have done it, and they'll use like different namespace prefixes or different tags to really separate it and still share the same OpenTSDB configuration.
Yeah, question on the forecasting. Can a forecast alert be configured on a collection of systems? Like, say you've got 5 VMs or 5 instances that comprise a logical service.
Can you just repeat the beginning again?
Yeah, can you, for forecast alerting, can you combine, say, the CPU of 5 VMs to create an alert, like we're going to run out of CPU or run out of memory or disk on this collective of machines?
If you had a specific tag on them, that would line up with OpenTSDB 2.1 aggregation. You could do that. Once we get the 2.2 filters in, then OpenTSDB is really going to handle that aggregation for you. And then you can add a filter to get the subset of servers you only care about if you don't happen to have a cluster tag. And then, yeah, it's going to do a point-wise aggregation of that time series if you leave that group by field blank. So, yeah, you'll get a time series that would represent that.
Only through OpenTSDB then?
No, it's any time series database. So as long as you can, basically you can do a forecast on any series. So if it'll give you that series. As far as taking series and maybe adding them up that not done by the database, I do have a branch that has some of those point-wise operations in it that I was working on about a month ago, and I hope to pick it up again after this conference. Yeah.
How do you handle just like true-false type checks? Do you still throw those in the time series database and then alert on those of just like 0 or 1, this thing is working or not working?
Yeah, for things like is a service running, it'll just be 0 or 1, and we say alert if it's not 1, or then you can start to do things like min. You might not want to alert unless the service hasn't been running for a few minutes because you have something that's a little volatile, unfortunately. So yeah, I think even just recording that stuff in a time series can be very useful, because then it also lets you do that historical testing, right? So if you're only using current state, you couldn't do that anymore.
Do you have a mechanism for handling debouncing of flapping alerts? I've seen systems where like you can have different conditions when you're not triggered versus a condition when you're already triggered, so you can make it come way low before you clear an alert.
Yeah, I added a function about a month or 2 months ago. It should be, I think, in our current release. It's called CChange, and basically that counts the number of times the value has changed in your time series. And I added that for something like interface flapping. So we, for instance, monitor the admin status, and you can count the number of times that it's changed within that time period. Is that what you're asking, or not quite? No, not quite. Sorry, do you want to repeat it?
Thinking like, say you've got a numeric threshold and you want to alert if it goes high for a sustained period, but not clear until it goes low for a sustained period.
Okay. So since Bosun really is about like a very accurate, disciplined approach to alerting, its state machine is a little bit different than you might be used to with Nagios. Once it goes to warn, it'll never alert again. You can set notification chain so it will alert, but by default, once it goes to warn, if it goes to normal, warn, normal, it's only going to alert about that first warn, or if it goes up to critical again, then it'll notify about that critical, but it'll never notify again if it goes lower, and that'll be the state until a human closes the alert. So it's really, this is really tied in with the idea of humans handling things. So there's no up notification. There is no up notification in Bosun. What there is there's notifications for human acknowledgement and humans closing it. So a human on the team, if they acknowledge the alert, you'll get sent that message in an email. And the philosophy behind that is that the inverse of a condition that triggered an alert often doesn't mean that things are okay, right? Like you need to go and look and see what's going on, and a human needs to interpret that. So there actually are no up alerts, and so that flapping prevention is actually just kind of natural in the way the state machine works.
Is this expecting a certain set of tags that are going to be provided by scollector, or could we plumb this to our existing InfluxDB time series data?
Yeah, there's no expected tags. You can use whatever you want. There's some features, like we added a host API for OpServer, which will display a whole bunch of information by host in JSON, like what are the disk drives, what is their current values, what is the serial number and stuff like that. And that's largely based on expecting data in a format from scollector. But in general, yeah, Bosun doesn't care what your schema is. So like Graphite was added after the fact, and that wasn't used with scollector and stuff like that. Basically, when you start to use those other ones, you lose that graphing page because that graphing page is OpenTSDB specific. So basically, you start at the expression page with your expression and go from there.
And we're out of time, so thank you very much.
Thank you. Everyone enjoy their dinner.